speaker is also from Clemson University, and I heard your Thomas sound great. This is Brian Williams, and I'm just gonna.
All right. All right. Thank you for being here today, and thank you for attending my talk. The goal of the South Carolina Water Resource Center project was a research and educational project that examined river flooding due to Hurricane Florence on the Winyah Bay region of northeastern South Carolina. Today, we're going to talk a little bit about the research and then the educational part of the project that was portrayed in a new way. 3D visualization has come a long way so that we can now do it with highly realistic images and animation, but it's still viewed through a 2D interface, namely the screen. Likewise, it's also usually pre-rendered, so there's very little interaction. Virtual reality technology has the promise of putting someone in a true 3D space so that they can view the simulation from any angle. Now, VR, the concept of VR has been around for a lot longer than most people realize. In 1838, Sir Charles Wheatstone was the first person to come up with the concept of stereopsis and actually construct a stereoscope, which took two 2D photographs and combined them into one 3D image. Continued research developed head-mounted displays in the 1960s and developed head motion tracking systems. By the 1980s, we had wired motion tracking gloves, which provided another system of interaction with VR environments. And by this time, it was the first private company that began selling VR equipment. Now, it was important to note that at the time, it was still large institutions that was using VR, namely universities, the military, and agencies like NASA. It wasn't quite in the hands of consumers yet. In the 1990s, several video game companies such as Sega, Nintendo, and Virtuality began experimenting with gaming systems. Most of these were really expensive or had limited amount of games, and they were mostly failures. By the 2000s, more companies began investing in VR. One of the most notable events during this time was the 2012 Kickstarter for the Oculus Rift system. This promised to have an affordable system that could be run on computer systems that most gaming and computer enthusiasts had, and it raised $2.4 million. Other companies such as HTC, Samsung, and Microsoft saw this happen and quickly began developing their own systems. In 2019, Oculus released their first standalone headset called the Quest, and it had a big advantage of being portable. It was not tied to computers at all, and it had a modern chipset that allowed you to have modern 3D graphics and sound. So it was a really big and important breaking point because that was not standard for most of these systems. Now, due to what was conceived as the large computing resources needed for constructing VR environments, they traditionally were very, very small. It was intimate scenes like a house or the International Space Station or some kind of, a training sim. There is very limited amount of movement. Now, this was either by design or just by the constructor's concept. It doesn't make sense to have freedom of movement in the International Space Station because it's small and confined, and you can't really go anywhere. And more open scenes, such as this balcony scene, You often have a pre-rendered background that promises to have a wider scope, but there are artificial limitations put in place that sort of still limit the user movement. In this case, you get onto the balcony and this is as far as you can go. You can't go and interact with the neighborhood in the background. There has been very little work done with VR in large scale, in the larger scale, especially in landscape. This, along with the affordability and the availability of the system as a Quest, led us to this project goals. Can a system like the Quest be used to visualize a large landscape level event? If we can do this, what are some of the limitations? And also, if we can do this, what are some of the ways to make it better in the future? The study area for our project was the PD watershed, which is on the outlet of the Winyah Bay, which is a portion of North Carolina and a large portion of northeastern South Carolina. Winyah Bay and the lower river systems are tidal, which makes flood prediction, flood prediction, understanding and predicting flood a little bit more difficult. As a pilot project, we selected a short section of the Great Petey River that's between the USGS gauges 3 and 4 on this map. Number 4 was the last gauge on this river system, and it measured the majority of the flow that passed by this river. The HECRAS model developed by the U.S. Corps of Engineers was used to predict the flooding. This model takes the floodplain and river and breaks them up into a series of cross sections. These cross sections are used to input the elevation data that relates to river hydraulics. The result is, I'm sorry. The result is a 2D XY portrayal of the flooding that uses color as a water depth. The individual solutions of each cross-section are interpolated to provide the solution, and the goal of our project was to take this final solution and portray it in VR. So to create this 3D VR experience, it had 3 major requirements. First, we had to portray the landscape in a realistic manner so that people could, if people wanted to view this, they could recognize where they were. The second goal was to visualize the river. And then the final requirement was to take the HECRAS flooding out results and display those results on the river. Now, the original plan was to import the DEM into Unity, which would create a grayscale surface, and then I'd paint the surface features with different textures and 3D models. This became quickly problematic because of just the sheer number of textures and 3D objects needed. It really slowed down the performance on the headset, and it could not draw everything fast enough to produce smooth animation. So I sort of had to go back to the drawing board, and I instead used a technique with the 3D program called Blender, which I used the elevation model to create a 3D surface. A high-resolution photograph was unwrapped around this model, and it followed the surface features to create a appearance of a 3D landscape. This was imported into Unity as just a single object with a single texture, which proved to be advantageous later because it made the headset was able to use this much more efficiently and produce better results. This is what the landscape looks like in VR. You can see various see the out. You're able to see the landscape from several different viewpoints, but you will immediately notice some places where there are anomalies, namely along the river where it appears to be a giant cliff. To produce a 3D surface, you have to exaggerate this. You have to exaggerate the surface somewhat. As it was explained in the last video, the coast of South Carolina has a very gentle slope. So when you exaggerate the slope, big differences blow up very fast. There are places along the river where there is a slope, and it is 10 to 15 feet on the side of the river, but it doesn't occur like this. There's no giant cliffs. Likewise, there are places where the river appears lower than normal. This can be observed at times, but this is another anomaly from the exaggeration. Now, to create the water, Unity has several pre-made surfaces, pre-made symbologies and surfaces called prefabs that are basically animations and 2D textures that simulate water in the landscape. So we took one prefab and laid it out along the course of the river to recreate the Great PD River. To simulate the HEC-RAS results, we laid out planes of water, and this was used to reproduce the cross sections. However, compared to the 48 cross sections that was used in the HEC-RAS models, we only used 5 planes of water to make it more efficient. It'd be very, very time consuming to work with 48 different planes at once in this model. To reproduce these HEC-RAS results, the river and each of these planes had their surface heights adjusted along a timeline. And when you combine these timelines with the surfaces being raised and lowered, it was it created a timeline which represented how the floodwaters came in and later receded after the flood. Can you please play the animation? Thank you. This is a 2D animation of the flooding occurring. As you can see, as these planes have their heights increased, it gradually fills in the landscape. This led to a really interesting result where I learned that one prefab cannot be used for the same purpose within Unity. When you make one change with prefab, it occurs to every other instance of that prefab within the environment. So that led me to investigate some of the other included prefabs within Unity, and I learned that they had some really interesting characteristics which had some really different results. This is what they call the advanced water. It is very realistic in appearance. It has transparency, so you can see the landscape beneath it. It has very realistic wave motion and can have real-time lighting effects and reflection, and it appears very, very realistic. However, it has a very short rendering difference. If you look down the floodplain, it disappears very quickly. And if you look at it from a high altitude, it almost disappears entirely and you cannot see it anymore. So it's great for viewing close up, but when you get any distance away, it disappears and is very poor. This is what they call their simple water. It's a little bit less realistic. It's not transparent. There is wave motion, but you have to be very, very close to see it. It doesn't have fancy lighting effects and very simple reflection and reflection values and lighting effects. What it does do very well is that you can see it from very far off. You can almost look down the entire floodplain and see the water. You can get up very, very, very high altitude and still see the floodplain and the water coming in. One thing I noticed that is when you're at very, very high altitude, it appears sort of shaky and jittery. And I don't know if it's some kind of animation effect, but it appears to be glitch out, but it is very, very good for seeing from long distance. Now, since we had both of these water options available, and I made a flooding animation with both of them, and you had a simple menu to choose from, depending on which model you want to see. So how does this look within VR? Can you please play this animation? You have a graph. You have a menu to choose between what graphics you want to view. Using the hand controllers, you're able to fly throughout the landscape. You have a little menu system that tells you when you can choose to play the animation and pause it. It was my intent at the beginning to have modern video controls, such as play, pause, fast forward, and rewind. That's unfortunately not the case at this moment. Unity has built-in controls for playing and pausing, which are very easy to implement, but fast forwarding and rewinding is still a work in progress. Also, as you see, you can pause at any time, but this is also sort of not working as intended because it pauses the entire simulation, the entire environment. And so you can't fly, but you can look around. And you can start it up again and continue flying around and looking at it from any angle. So we were able to use the Oculus Quest to produce a large-scale landscape event. However, we ran up against several limitations. There was limited support for a lot of 3D objects and textures. If you used a lot of them, it could not draw them well enough. The drawing distance was limited with a lot of prefabs and by some of the prefabs and just the default distance was very, very short. Some of the special effects led to exaggerations, as we saw in the DEM. And there were frames per limits used due to processor speed and the resources for animation, especially using our advanced water, we're right up against the lower limit of stable frames per second. We also learned that efforts should really go to making your main subject as realistic as possible, and then follow up with everything after that. And then finally, optimization of the VR is very, very important. I really didn't use there was very limited amount of real-time lighting effects, shadows, or reflections. I didn't really have a lot of objects physics, so theoretically you could fly. You can go and fly beneath the surface of the river. And I really couldn't use graphics with a lot of big heavy textures because they were very inefficient. And using bake lighting is a must. Bake lighting is a term used within the graphics industry, and basically it's pre-rendering all your real-time lighting effects so that it appears to be in real time, but it's actually it's processed ahead of time, and the headset is merely displaying with the graphics. It's not computing them in real time. Future considerations for further, if I want to do further work in this, is that I want to use the lightweight rendering platform within Unity 2019 and above. This was a platform that was developed for systems like the Quest that uses these low memory systems to render textures in a more efficient manner and hopefully to get fancier graphics. It was just not available when I started this project. There has since been a feature called the link system where you can take where you can take the headset and use a USB cable and connect it to a computer. And it becomes usually a dummy terminal. And I want to convert this program into a Windows executable and use the computer to drive it. But eventually, essentially, this gets it back to the original problem of tying you back to a computer. But there was just a new feature released within about the last 6 months where you can do this over Wi-Fi. And it kind of creates the best of both worlds. You had a computer driving it, but you still have the freedom of being portable. I'd like to acknowledge our partners in this, the South Carolina Water Resources Center for funding this project, the volunteer work done by Jim Hendricks, who did a lot of outlining of these cross sections. He was a very big help on this. And for Jeremy Forsyth, which directed me to a database for high resolution area photography and really made the Blender system work. I do have our headset available. So if someone is really brave and would like a live demo, I can do that during the break. And I'm now open for questions.